Welcome to my YouTube channel scientific_math. Today our topic is continuity, and in this lecture we discuss continuity from left, continuity from right, continuity over an open interval, continuity over a closed interval, continuity on an interval, and continuity over an interval. So first we have a continuity from left. We discuss the definitions of all these continuity from left, continuity from right, and all these. So a function f of x is said to continuous from the left at a point a if and only if the left limit of the function is equal to the value of the function at a. And next we have a continuity from right. A function f of x is said to be continuous from the right at a point a if the right limit of the function, okay, is equal to the value of the function at a. Continuity over an open interval. A function is continuous over an open interval if it is continuous at every point in the interval. Okay, next we have continuity over a closed interval. A function f of x is continuous over a closed interval of the form ab, and if it is continuous at every point in open interval ab and is continuous from the right at a and is continuous from the left at b, then we said the function is continuous over a closed interval. Now continuity over other types of intervals are defined in a similar fashion. If the right limit of the function is equal to the value of the function at a, left limit of the function at b is equal to the value of the function at b, ensure that we can trace the graph of the function, the point this one, that is a and f of a, to the point b and f of b without lifting the pencil. Yes, when these conditions hold, and when as limit x approaches to a and is equal to the value of the function, okay, and when the limit of the function as x approaches to b is equal to the value of the function at b, and these hold, this mean the function is continuous, there is no discontinuity. Okay, if for example as the limit of the function as x approaches to a is not equal to the value of the function at a, then what happen, we would need to lift our pencil to jump from the point f of a to the graph of the rest of the function over this one over interval. Okay, so there will be a discontinuity when this will happen, when the limit as x approaches to a of the function is not equal to the value of the function. Okay, now we have a continuity over continuity on an interval, and here we have an example, state the interval over which the function, and that is continuous. So since this is our rational function and it is continuous at every point in the in its domain, and the domain of the function is the set that is we have. Okay, so continuity over an interval, here we have an example, state the interval over which the function f of x is continuous. So from the limits law, from the limit laws, we know as the right limit as x approaches to a, this is equal to under root 4 minus a square. For all values of a in this interval -2 and 2, we know that as limit x approaches to -2, this will be equal to 0, that is limit of the function is exist, and when the limit of the function as x approaches to 2, this is also exist, that is equal to 0. Therefore f of x is continuous over the interval -2 to 2. Okay, now we have a example. Next example, state the interval over which the function f of x is continuous. Okay, we know that the function f of x, when we put over -3, then it will be equal to 0, and when we put 2 and -2, -1 and 0 up to infinity, infinity, the function will be continuous. There will be no discontinuity, and the limit of the function will exist. So the function interval for this function is with closed and -3 and infinity with open end. So this is half closed interval we have. Okay, so thank you so much for watching my video, and please subscribe my channel scientific_math.